inviting and for the invitation. I'm in charge of work package 6, where we are going to all together in the rebuild project to come up with some guidelines for what how can we insulate. But this work is actually going on the next 4 years. So what I'm presenting today is a kind of future scenario of how it could be in 4 years' time. But we also need it for the development, because we had a meeting in Riga in December, and we found out that to do the proper work in the work package 2, 3, 4, and 5, where we actually are doing all the research, we have to know what we expect. I mean, what are we working against? And I have, together with Tessa, my PhD student, tried to give an answer to that. Right, okay. Rebuild will in 2020 result in guidelines which will help practitioners to determine whether a building is suitable for internal insulation and which solution to choose. The guidelines will be applicable to buildings in EU. There are some limitations. We are only looking at the EU countries. We are only looking at buildings from before, which are built before 1945. And we are only looking on the heavy external walls made of stone, brick, or half timber. And we are only looking at walls exposed to outdoor climate. So we're not looking at walls between a colder or warmer room inside the building. It's only at the perimeter of the building. The following slide is an example on how the user interface could be for such guidelines. So what we think is that we build in the guidelines in a user interface, so you will not kind of see them as guidelines, but as information when you go through this user interface. And with the knowledge we have up to now, I believe that you can put internal insulation on all walls. But it's just a matter of how many millimeters. Maybe if you go through this exercise, you will be told that you can only put 5 millimeter insulation on your wall. But this is kind of what I think now. Maybe we get more wiser later on. But this presentation is made out from that context. So actually what we come up with is a number of millimeters of internal insulation which can be put on an external wall of a specific building. So what we think is that first you have to put in some data on the building you want to look into. And afterwards you decide what interior insulation you put on. So we choose the existing building. We think that we need to choose a country, because you have specific rules in each country. So we think we have to in the machinery behind this do calculation for each country. So we choose a country. We are in Denmark, so why not choose Denmark? We also think we should choose a climate zone in a country. So we think we are in North Jutland, so we choose climate zone 1. We think also the orientation can have an impact on hydrothermal conditions. Every orientation is added, calculated individually. So if you have more walls, and you often have in a building, you have to calculate each wall. So the next thing is that you turn the compass to the direction of the wall. So we choose a
surface of the wall, which is facing 240 degrees southwest. And then there are different external wall types dated before 1945. Rebuild deals with these three main types, and we choose the external wall made of brick. And then we have to tell the database that if you have embedded wood in the construction, it can increase the risk associated with internal insulation, and this must be considered. So you have to choose whether there are wooden beams or no wooden beams. We think there are wooden beams. Then we think it can be important whether you when the building is built in these three periods when you are in Denmark, because we have some legislations at these times, and that could be different in other countries. So maybe there will be other periods in other countries. In this case, we choose 1889 to 1945. And then the condition of the facade can be vital in regards to internal insulation. So you have to make sure that your facade is intact. If not, proper repair must be made. And if you want to know more about that, then you click on the facade is damaged, and there you will get information on what you should do in order to that you can put on interior insulation. Today, I believe that if you have a deteriorated facade, you should not put on interior insulation. So we say that our facade is intact, and prior to internal installation, the interior walls must be stripped clean. We heard probably from the last presentation that you have that has been done there, and therefore, if you already have done that, you can click on the interior wall is all ready for installation, or if not, if you click on the is not ready, then you will get information on what to do. So we choose the interior wall is ready for insulation. Then the exterior surface of the building has influence on the hygrothermal properties of the wall. So since we choose brick wall, exposed brick wall, it can either be exposed, impregnated, painted, render, or render with paint. So we choose one of these, and this example we choose exposed. And the type of wall construction is essential for the insulation. So whether it's a cavity wall or solid masonry, we choose solid masonry. Then the thickness of the wall also have an important influence. And here in Denmark, we used to talk in half bricks. So I have done it this way, but it could also be done only with millimeters. But we choose a wall which is 1.5 brick thick. Then the capillary suction of the exterior surface determines the impact of external wall sources. For example, wind-driven rain, which is quite important when you put up interior insulation. So we recommend that you go out with this small piece of plastic, this carbon tube, and by clicking on the link, you will be told what it looks like, where you can buy it, and how you do it. But you just glue it to a brick, put some water in it, let it be there for 15 minutes, and you find out how many millimeters of water has been absorbed, have been drained away from the tube, and you put that into that number into absorbed water, and then you measure. There will be a wet ring around where it's fixed, and you measure the diameter of this ring. And you do that for the brick, and you do it for the joints, so you also put it on where you have two joints. You put in the measured data, say OK. If more complete information about material is given, we can do more detailed calculation. Otherwise, the safety factor will be increased in the database. We will use kind of worst case. But if you have materials with better data, then you will probably get a better solution, meaning that you can put more millimeter on the wall. So in this situation, we choose that we have detailed calculation. But if not, you will just get kind of, maybe you could have had 50 millimeters, but now it will come out with 40 millimeters, because we're taking the worst case. Oh, sorry, that was back. So we choose this detailed calculation, and then we should talk about the brick or the mortar, and we choose the brick. And sorry, I go back. We choose the brick, and then you can put in a lot of good data, so you get this better answer. And you can click on the method, and you will get information on how you actually do this calculation, or how you get this information. But it's not only calculation; it's also to make some experiment with materials. So this is, I mean, not many is doing this, so it will be a kind of special way of doing it. But let's say that we have all this data, the density, the specific heat capacity, the open porosity, the thermal conductivity, the capillary suction, and the water vapor diffusion resistance factor. We put this data in and say, okay. Existing moisture conditions in the wall affect the hydrothermal response of internal insulation. So type in the moisture content in the 3 measuring areas. And how do we do that? We click on the link, and we use this very simple method by using a 10 millimeters thick and 10 centimeter long drill. We take out the powder from the brick, and we put it into a sealed test tube and send the sample to the laboratory. And this way you will get an answer on how wet is the wall. When you have done that, you go back and fill in these results you have received from the lab. And in this case, we recommend that you do it under a window, between some windows, and under the roof somewhere. Now there is a summary of all your input, and since we did all these material parameters, we have all this, and we have also measured the moisture, but otherwise this data is what we get if we get the quick way through. Now we continue to the choice of interior insulation. So to the left, you see the different materials which actually are on the market, or you can get. We plan to put in the manufacturer of these different insulation materials, and they have different products which can be used. And in this case, and also they have different thermal conductivity. And this is either coming from the company, or we are doing some lab tests to find out whether it's working this way. And then the results, because of this wall, all the data has been put in, it comes out and tells the max insulation thickness depending on which material you are using. And also the U value you will obtain. So if we choose Ventroflex, we can put 90 millimeter insulation, on the interior surface, and we will get a U value of 0.542. And then we put this wall, then we click on Introflex and find out that they don't have 90 millimeters. Shame on you.
So what do we do?
We choose 30 and 50, that gives 80. So actually we have less insulation now if we choose this material than we can have. Okay. Then we have calculated one wall. And then we do it with the other walls also. And the total will come up here. So we add more walls. And now we have the total of these 4 walls. So we are having a heat loss reduction of 742 kilowatt hour per year. We will have an annual CO2 reduction of 128 kilos. And our from production of the material will be 416 kilos. I'm not guaranteeing for the figures here. So this is actually what I would say about this. That could be a user interface in the future when we know about how all this is working, all these different elements, exterior, water, interior, humidity and so on. Yes.
Thank you very much. Very, very simple and a nice shortcut to a very difficult decision.
No problem.
Who is the target group for this software?
This is the practitioners.
Yes. So we're talking about skilled people using this.
Yeah. Skilled people. Yes.
Okay. Interesting. You guidelines. Your comments, please. Do you buy this product? Are you ready? Are you the target group for this? Any considerations here?
A simple question about the measure of the walls. Would you have to put it in the value of the measure of the thickness of the walls? Mostly the buildings have different thickness depending on how in where a story you're calculating. So do you make do you make a calculation for each floor, or do you take all the thickness and then divide it by the stories?
No. It was said in the slideshow that you actually have to go through this exercise with each thickness of wall.
Okay.
And then you add the different walls, and then you can get this average. But you need the data for each wall.
Okay.
And it can be different. I mean, if you have a thicker wall, maybe you can put more insulation on it. But then you can choose to use the minimum size to all the walls, or you can decide to put different layers on it.
Would you have to, when you're measuring the content of water in the existing brick wall, would you have to put in a date, a month, a year?
Yeah,
And would you have to do it for like the different thicknesses of?
I believe that what is important here is the wetness of the wall when you actually apply the insulation. So you know, I mean, what to look for. So this is the time when you apply. So if it's 1 year old measurement, then maybe it's not very good.
Okay, other questions or remarks? Yes, please.
How much does the thickness of the insulation elevation change depending on the orientation of the facade?
I don't know, Philip. That's what we're going to find out.
It looked like you knew.
That's a very good question. Do you have any ideas or hypothetical answers to that? Is it
In Denmark, we think that the southwest facade is there where you have most driven rain. So I would guess that there you will have a more challenge than the others. But we also have problems with the northeast wall because there's not much sun to dry it out. So we have to find more details about that.
Okay, more questions? I have only one. Have you calculated the time being used for doing this test or at each level of the building? Do you know how many hours we're talking about for a man to do this?
I mean, a practitioner who wants to test this what?
There's an economy in this test, and there's some time.
Yeah. It depends on if you're going to make all this material data, if you don't have them.
Yes.
Because if you go the easy way through,
Yes.
it will not be very time consuming, I guess. I mean, this carton tube, 15 minutes,
Yes.
but you have to go out there, maybe you have to climb up on the facade and so on. So there are some work. So it is a practitioner who's going to, I think, could do this job.
Yeah. Okay.
Maybe Technological Institute.
Sam will have to leave us, but if you have any questions, then it's now, you know, and we'd like to have your comments if this guidance is useful or yes.
This is a very, it's a technical way into this field, and you say it's for the practitioners, but would it be relevant to have some kind of fail-safe for, of course, hopefully the practitioner will see if there's a fantastic stucco or wooden panels or something in the interior of these buildings, but is that thought into this, that there might be a question mark?
A kind of warning system here.
Some kind of way.
Yes, there should be some warnings coming up, but are you sure, for example? But the good thing that it should be a practitioner, maybe an engineer, an architect, is that they have a good insurance. So if you tell this database that it's different and you go out with a result, then you are in trouble.
But there might be some issues here or some concerns that could be built into the garden. Yes. Other questions for Søren before he leaves us? Otherwise, thank you very much, Søren.
Thank you.
We're looking forward to these guys.